All right, CNT125, we're taking a look at Chapter 7 on network architecture. Here's the overall objectives for our Chapter 7. We're going to divide this up into a handful of podcasts to go through the chapter. First section, they start talking about like software-defined networking, but they do just a teeny bit of stuff on switches. So let's do a little bit of discussion on switches before we get into their software-defined networking. Switches are designed to break a network into little pieces, segment the network at a layer 2, if you will. That's where traditionally switches operate, layer 2. Switches are typically going to read and interpret MAC addresses at layer 2, and it usually maintains a table of MAC addresses. In there, the table, if you will, is the ports on the switch and what MAC addresses it has learned that are on those ports. So as devices start sending data through switch ports, it goes, well, I think this MAC address is over here because they're the ones that sent it. So it starts maintaining those MAC addresses in a table. So then when data needs to come back through, let me go back here. As data now needs to move through the switch, when the switch receives that frame of data, it's going to look at where is it going. Oh, it's going to this MAC address. Let me check my table. Do I have that MAC address in there? If it does, it's like, cool. I know it goes to this port 4 or port 5 or whatever. And it tries to send it to only that port, only that destination. So because it does that, we can now have, as this a very simple picture shows, we can have computer 1 and 2 sending data back and forth at the same time computer 3 and 4 is sending data. So the switch was able to break the network into pieces by having this table of MAC addresses and sending data to only the intended recipient. And because it can do that, it can actually have multiple conversations going on at one point. This was a huge advantage over hubs that were used previously. So switches, typical layer 2, typically reading MAC addresses and moving data to the intended recipient. And here's a handful of different switches, 24, 48, and a chassis grade switch. These are various types of switches. They're all going to function in that similar manner. Switches also have, as we look at the ports over here, these ports over here can be 10, 100, or 1000 meg. And then off to the right are typically some uplink ports. Well, as I look at these switches, if these over here are, 10 meg ports, these uplinks over here would be typically 100 meg. If these are 100 meg ports, these over here would be gig ports. If these are gig ports here, then this is going to be a 10 gig uplink. That's typically how these are done. And the uplinks, these are usually connecting to other switches or routers or other data closets kind of thing. So all the traffic on these ports here has to get combined together to go across this uplink to another switch, to another closet, to another router. So typically, whatever the port bandwidth is here, if it's a gig, this is going to be a factor of 10 more or 10 gig. That's typically what you'll find on those switches. If I crack them open, I'll find it basically is a specialized, computer motherboard, if you will, designed to move traffic in and out. So basically a series of NICs in here moving data in and out of the switch. Switches can come in either unmanaged or managed fashion. Here's managed, unmanaged, and managed. Unmanaged is the type of switch, let's say you go to a store like a Staples, Office Max, Best Buy, that kind of thing, and you buy a switch to take home and hook up to your ISP router because you want to plug your PlayStation, Xbox, Switch, Nintendo Switch in to an actual switch port. That switch that you would buy for home is typically going to be an unmanaged switch. You pretty much plug and play. It really has no management capability, has no capability for me to log into it and do any changes on it. So an unmanaged is pretty much just a layer 2 plug and play switch. Meanwhile, they do make managed switches. Managed switches are the kind of thing you would have in a business, if you think back to your high school that you came from or school that you came from, the switches in those data closets were most likely managed switches because a network administrator was connecting into them and making setting changes on them to change how the network functioned. And they were either browsing in through a GUI, through a graphical user interface, or in through a command line, and would actually put commands in to change the function of the switch, how it was functioning. And you would typically put an IP address on so that you could get to it remotely for management purposes. These are all things we're going to do when we're in Chapter 8. When we do Chapter 8 with VLANs, IP addressing, subnetting, that sort of thing, we actually configure switches and do these kind of tasks here. So let me show you real quickly in the next page. This is browsing in through a website to get to a switch and make changes on the ports. This would be kind of a small business type switch, or you might actually connect into a command line, run some commands on it. This is the kind of configuration we'll be doing on our switches. The switches we have in our lab rooms are actually, business grade switches. They're kind of like medium to large business grade switches where you're actually going to connect into them, run commands on them to make configuration changes on them. Switches can also be layer 3 and layer 4. Now, on the outside, they're not going to look much different, but the operating system on the inside of the switch is different. If it's a layer 2 switch, it's now going to read and interpret layer 3 data. We typically think of layer 3 data as IP addressing. So a layer 3 switch is going to read and interpret IP addresses and move data through the network. Now, just remember, it's still a switch. It's not a router. It does not have all the functions of a router. It doesn't have all the capabilities of the router, but it's able to do basic routing, but it's able to do it at like the speed of a switch, because a switch is able to move data through quicker than a router can. So it's kind of that middle of the road. It's like, well, I can read some IP addressing. I can't do all the fancy features a router can, but I'm going to move data through pretty quickly. You can also have a layer 4 switch. Layer 4 is going to read and interpret layer 4 data. Well, typically layer 4 data that we'd be reading and interpreting is TCP and UDP port numbers, if you will. So a layer 4 switch could read those TCP and UDP port numbers moving through and make some basic decisions. Oh, you're trying to go to the web server? Go ahead. Oh, you're trying to do something like Telnet, which we don't want on our network? No, we're not going to allow that. And again, they're not going to look any different. I'll go back here real quickly. You could have this guy right here be a layer 2 switch or a layer 3 switch, and the outside would not look any different. It's the operating system on the inside that is where the difference is. So you need to know the capabilities of that switch. This up here could be something that's in a layer 4 category. This could be layer 2, layer 3, or layer 4. But this might have layer 4 capability on it to do some additional decisions on the data moving through. And again, that can be an asset in your network to filter or I hate to say permit or deny, but basically limit traffic right at that point versus waiting till you get to another device like a router or firewall to limit that traffic. And again, here is, command line interface, or browsing in GUI interface or command line interface to configure those switches. Now switches, because they're moving data around and making basic path decisions, but they're not as intelligent as a router, they can actually create what are called redundant loops in your network. So let me go here real quick. If I have a scenario like this where, computer to computer, there's more than one path to take from this computer over here to this computer. So if I were to send data this way, and all of a sudden this computer goes down, you could have a scenario of like, oh no, check this one. Oh no, check this one. Oh no, check this one. And it literally starts looping the network, if you will. Or you can have a scenario where it's trying to broadcast to find it because it can't find it, and this broadcast, this picks it up, this broadcast, this picks it up, this broadcast, this picks it up, it broadcast, etc. So when you have more than one path in a switch environment, there can be redundant loops or broadcast storms created because of that. There's more than one pass, because the switches aren't quite smart enough to maintain both of those paths to move data through. So what typically gets implemented is STP, Spanning Tree Protocol. Spanning Tree Protocol defined by IEEE 802.1d. This actually looks for these redundant paths and artificially blocks one. I'll go back here to a slide. It's actually going to artificially block that and go, yeah, that road's closed right now. Wink, wink, nudge, nudge. That way it moves traffic this way through the network. But if this were to fail, then this could come back in line and actually be there to move data through. So that's what STP is going to do. As we do Wiresharks in our networks with switches, you're going to see STP traffic move through, even though you did not purposely configure STP. It's going to be there. To do this, your switches, the switches are going to like basically create a root bridge. The one that's basically it's a combination of 2-bit priority field that can be set by the admin and the MAC address. All your MAC addresses in there, it's going to like, hey, what's the highest one plus the priority? That becomes the root bridge. And that's the one that's like, okay, we're going to put this in a redundant, we're going to block this path, we're going to block this path. It's going to be the one that acts like the one in charge of the network, looking for these redundant paths and putting one in a blocked state, if you will. So you have this network here that root bridge is going to go through and say, let's block these redundant paths. Okay, now we're going to move our traffic through. And then if we have a failure, one of these block paths can be opened up and we can continue moving data through. That's what STP is going to do. There is other versions of this out here. Different manufacturers have developed, these that are listed here, and you might end up seeing these in some networks if you're Wiresharking. You might see those protocols moving about. And some of these are proprietary to the equipment manufacturer, but they're all kind of like a derivative of STP. On switches, you can do some port security. On your switch, all those ports that are there, if somebody were to plug into a different port, they might have access to a different portion of the network you might not want them to have access to. So one thing that can be done is you can literally just disable the ports that aren't being used. You shut them down. So you can plug into them all they want and they will not turn on. You will not have access. So if somebody were to take their laptop down the hall and plug into a network outlet in the manager's office, that port that's there, if it's just, hanging out, they might actually have access to manager type applications. Well, if that port's not being used, a good security feature is you shut off that switch port on the switch. And, a command line, go in and take port 32 or whatever it is and shut it off. That is real basic security. It's one of many pieces of security in network that you can do. That's a real basic, one layer of defense, if you will. The other thing that can be done is you can actually go in and configure the switch to only allow one MAC address on. So if somebody were to try to unplug the manager's computer and then plug a laptop in, the switch would go, hey, I'm sensing a second MAC address on here, and it alerts and shuts that port off. And I show you the command sequence here to do this. You go into the port, you say port security, you say maximum of one MAC address, if you will, and you turn on the sticky feature where whatever MAC address it first learns it holds on to. So again, if the manager computer, I try to unplug that and plug my laptop in, it's going to, I sense a second MAC address, and it'll shut that off and shut off that port. Shut off that port and moving data through. Again, another piece of a larger security plan that is something can be done at the switch level. These are all possible through managed switches. Okay, we'll come back to the next podcast and continue on.